Hello, good morning, good afternoon, good evening to you out there wherever you're in the world. This is Samuel and Ekan welcoming you to this channel, welcoming you to this lesson. So this is our series on density. So today we'll be looking at Upthrust. This is lesson 5 so far on our series on density. So we'll be looking at Upthrust today. So before we continue, I would like you, if you're not subscribed to this channel, just go ahead and hit the subscribe button and also hit the like button because you are actually going to enjoy this lesson today. So we've actually gone through lesson 1, lesson 2, lesson 3, lesson 4 on density. In our last lesson we looked at relative density, and at the end of the lesson we actually solved a calculation, we solved a problem. So in this lesson we'll be moving over to Upthrust. Now, what is actually Upthrust? What is Upthrust? Upthrust is actually a force. It's a force actually. But what does it do? Now, for those of you who have actually drawn water out from a well, you will observe that when you throw your bucket into the well, the bucket you want to use to draw water, or the container you want to use to draw water out of the well, when that container enters into the well and is submerged in the well and it goes down deep down into the water, as you are trying to pull it out, when that bucket of water or container of water is inside that well, the bucket appears to be light. As you're drawing it out, you feel like it's light, but immediately the bucket comes out of the water in the well, the bucket appears heavier. So why is it? Is it magic that the bucket actually appears lighter once it's inside the water, inside the well, and immediately it comes out of the water, it becomes heavier? No. The reason is that while the bucket of water is inside the well, there is a force pushing it upward. There's an upward force, and that force that is pushing it upward is called the upthrust. So at the end of the day, while that bucket is inside the water, it appears to weigh lighter. The weight is not the real weight you have when it's outside. The weight is actually smaller. So if you were to attach a spring balance to that bucket, when it's outside the water, you discover that it's heavier. Once it's inside the water, inside the well, you discover that the rate of the spring balance is going to be lower than when the bucket is outside. So that force is called the upthrust, or it can be called buoyancy force. Buoyancy. So that is what we're looking at today, upthrust. So let me quickly draw the sketch of the well of water, and just to illustrate what I have just explained now. So I have actually sketched the well. Now before I continue with the explanation, I just want to say something about the word fluid, because in density upthrust we will deal a lot with what we call fluid. What is a fluid? A fluid can be a liquid or a gas. The word fluid is a terminology that is used to classify both liquid and gas. It's a general term for liquid and gases. So we will do a lot with fluids in density. So like I was saying, this is our well. The same thing can happen even if you are fetching water from a stream or from a river, from any body of water, a tank of water or anything. But let's just say that this is our well right now. So right here, this is the bucket. This is the bucket. The bucket has been dropped down into the well. It is completely covered by water. Now we have upward force, upthrust, from the water acting on the bucket. This force now is pushing the bucket upward. So when you try to pull, you want to pull this bucket, the force with which you pull is going to be less. But when the bucket comes out of this water now, which we have here, at this point The bucket is now filled with water. The bucket is filled with water here, but it's still filled with water here. It is out of the well. It is out of the water. There is no more upthrust here. So the bucket is going to be heavier. Now the bucket is now in the air. So the bucket is going to be heavier than it was when it was inside the water, because right now there is no upthrust acting anymore on it. So let's assume that the weight of the bucket in air is W sub A, while the weight of this is the weight of the bucket in air, and this is the weight W sub L, the weight of the bucket inside the well of water, which is a liquid. Actually, that's why I'm using W sub L. And if U is representing the upthrust, we know definitely like that on a way, if you were using a spring balance to measure check the weight of this bucket, the spring balance here, while the bucket is submerged, the reading will be smaller than the reading the spring balance is going to give you when the bucket is actually out of the water. Okay, so we have that weight in air is greater than weight in liquid. Weight in liquid is less than weight in air. So at the end of the day, how do you calculate the upthrust? The difference between the weight of the bucket of water in air minus the weight in the liquid, which in this case we are using water, gives you the upthrust. So upthrust U is equals to weight in air minus weight in liquid. So this is the upthrust here. So how can you define upthrust? Upthrust can be defined as the apparent loss in weight due to a upward force acting on a body immersed in a fluid, immersed in a liquid, immersed in a gas. So you can actually define upthrust as a apparent loss in weight. Apparent loss in weight. So when the bucket was here, there was a loss in weight. There was a loss in weight. The upthrust is apparent loss in weight due to an upward force acting on the body immersed, either partially or completely, in a fluid, which may be a gas or a liquid. So that is actually the definition of upthrust. So we can actually define upthrust as the apparent loss in weight of a body, of an object, due to upward force exerted on a body or exerted on that body when it is partially or totally immersed or submerged in a fluid. Okay, so this implies that whenever a body is immersed in a fluid, it's going to experience a loss in weight. It's going to experience a loss in weight. There will be an upthrust, an upward force that acts on the body. Okay, that is the implication. So there will always be an upward force acting on anybody immersed, either completely or partially, in a fluid, and that upward force is called the upthrust. That upward force is called the upthrust. The upward force is called the upthrust. They can call it buoyancy. That upthrust can also be referred to as loss in weight, or you can use the word apparent loss in weight. Okay, apparent loss in weight. So like I said, if the weight in air is WA and the weight in the liquid is WL, the weight in the fluid is WL. If we're using the liquid as a fluid in which that body is submerged, either partially or completely, then the upthrust U is going to be U is equals to weight in air minus weight in the fluid.
which is WL. We are using the liquid as a fluid now, so that WA minus WL. So that's how we can actually calculate the upthrust. So WL is the apparent weight of the body when immersed in the liquid. WL is what? The apparent weight of the body when immersed in the liquid. This is the weight when immersed in the liquid, the apparent weight. U is the upthrust or loss in weight or apparent loss in weight. This is the apparent weight, or you can call it the weight in the liquid, the weight in the fluid. So upthrust is a force actually, so it's measured in unit of Newton, and like force is a vector quantity, so upthrust also is a vector quantity. It has direction upward. Upthrust acts upward, so it has direction. It's a vector quantity as well. So we are going to take a quick calculation right away. We are going to solve one example on how to calculate upthrust. So in this case now, we have a solid weighs 147 Newton in air and 97 Newton when totally immersed in water. Calculate the upthrust, the loss in weight, the apparent loss in weight, and the apparent weight of a solid in water. Now, so WA, we're going to solve right now. We have WA is the weight of the solid in air, which is 147 Newton. Then we have WL, which is the weight of a solid in liquid, which in this case the liquid is water. That is 98 Newton. So the upthrust U is equals to the weight in air minus the weight in the liquid, which is water in this instance. So we have 147 Newton minus 98 Newton. So this is going to give us 147 minus 98. This gives us 9. This is 49 Newton. 147 Newton minus 98 Newton is 49 Newton. So the upthrust is equals to 49 Newton. Upthrust U is equals to 49 Newton. So what is the loss in weight? Loss in weight is also the upthrust, is also equals to 49 Newton. So what is the apparent loss in weight? Apparent loss in weight is 49 Newton is equals to the upthrust. Then the apparent weight of a solid in water. Apparent weight is the weight of the solid in water, which is 98 Newton. Okay, so we've calculated all the parameters that we need, and with this we've come to the end of this lesson for today. So I hope you actually enjoyed the lesson. In our next lesson, we'll be moving to Archimedes principle. Archimedes principle. There's no how you can do density upthrust without looking at Archimedes principle. Archimedes principle is critical. So in our next lesson, I'm going to explain Archimedes principle in detail. So you need to have a clear understanding of what upthrust is before we can delve into Archimedes principle. And I know you've actually enjoyed this lesson. And watch out for the next one. Invite your friends, share the videos with your friends, with your loved ones, and please, if you know you're not still subscribed to this channel, ensure you hit the subscribe button and the like button and drop your comment on how we can actually help you better. Then in case you need a one-on-one lesson, you can connect with me via WhatsApp. My WhatsApp number is just there. That is +234 803829
5185. So we are going to meet in the next lesson. Bye.